Hi, my name is Ray Beck. I'm CTO of a company called Element 55 over in Cambridge, Massachusetts. And I'm here today to talk to you about machine learning and why we, as React Native developers, are uniquely positioned to take advantage of this technology to create superior experiences for our customers and for our users in the coming weeks and months. But to understand why that's the case, we need to understand what machine learning is. And I think a reasonable working definition is machine learning is a science of teaching computers to write code and using the code that computers write. In fact, I find that machines like to write functions that are idempotent and pure. The science of getting these machines to write this code has been advancing really rapidly, even as recently as just the last 5 years, using deeply layered sequences and graphs of operations in even more traditional supervised settings, using objective functions and iterative techniques that lead to the kinds of advances associated with AlphaGo, if you've seen that documentary, and being able to transfer understanding across domains. But what all of them have in common is that they're about teaching computers to write better functions that generate more insight while requiring less data and using less computational horsepower both to create the function as well as eventually to run it. Now, at the same time, we have supercomputers in our pockets. And the state-of-the-art systems on a chip that we have driving our phones today are roughly 6 times as powerful as what we had as recently as 3 years ago. And they're now capable of running tens of billions of operations every second. In the case of BIONIC, hundreds of billions of certain types of operations useful for machine learning. And we now have more computational horsepower than we can actually use with most of our apps. And that's actually good, because machine learning functions are exceedingly mathy. It shouldn't really surprise us that computers are mathematical creatures, and what they're going to be best at is creating functions that involve a lot of math, and particularly high-dimensional math, and really transforming one kind of high-dimensional number into another, where a high-dimensional number is best described as just a big multi-dimensional array of floating points like you see up there. And in order for us to do that transform from the input to the output, the machine learning function does hundreds of thousands to tens of millions of operations in the middle to go from point A to point B. But as mathy as that is, it's hard to keep that in head. It's worth us remembering as consumers of machine learning, this is just a function. It's just a function that's really useful across a number of domains. And a few, like the ones that are up here, are about taking things that can be described using high-dimensional numbers that exist in the real world and bringing them to bear in context that we can really use. And rather than describing them in terms of technical specification, let's look at them from the point of view of what questions they answer. Like from computer vision taking face recognition and combining that with image classification to understand who is it who's in front of me. Being able to take GPS and combining that with a regional CNN to identify a wall that's in front of me to understand with a high degree of precision where I am and what my orientation is. Put a different way, it's taking this somewhat blobby sensory information that can be described using high-dimensional numbers. Images respond to this, waveforms respond to this, vectorized text responds to this, and turning it into usable context that can then drive our decision-making. Now, over the course of the last year plus, Apple and Google have been trading iterations on deploying technologies that allow us to run these machine-created functions directly on our phones. In the case of Apple, they call this technology CoreML. And in the case of Google, they call it TensorFlow Lite. But what they have in common is the ability to take this sensory information and turn it into context directly on your device, which means that the profile between the CCD of your phone's camera and the ability to make good decisions has the same relationship as your eye has with your brain, traveling a matter of centimeters. So it's quite fast, and not having to be shared with anybody else. It's as private as the thoughts in your head. But what really excites me about it is the personalization opportunity, by which I mean this, that in the case of both Apple and Google, they have introduced this technology primarily as a file specification. In the case of Apple, they're using protocol buffers. In the case of Google, they're using a variant called a flatbuff. But what both of them do is take advantage of a dirty little secret about machine learning, which is that the vast majority of machine learning functions are actually the arrangement of the same relatively finite set of high-level operations into different kinds of graphs and loaded up with different kinds of covariables and constants that the data science people call weights and biases. And because it's articulated as a file specification, a relatively high-level one, it is actually interpreted at runtime. That means it doesn't have to be compiled with your app. That means it doesn't have to go through the App Store. That means it can be downloaded whenever it's going to be useful, and it also means that your function doesn't have to be your function or my function. And we should actually be pretty familiar with this idea, because treating your code as an asset, that's what React Native is all about. That's what allows the dev server to work. That's what allows Expo to work. That's what allows even code push to work, this idea that we can have code that enhances our decision-making at runtime. And because of that, I can pull down classifiers or functions that are going to be relevant to me and in my circumstance. And for example, a differentiator that's able to tell the difference among members of my family doesn't need to be also aware of how to tell the difference among, say, Kent Dodds' family. And that allows us to have context, beget context, and create a much higher level of precision of how we can understand the world around us. And therein lies the opportunity for us as React developers. Because reality is the ultimate exogenous variable. Reality is. We all react to it. And if you only take one thing away from this talk, I hope it's this: that these machine learning technologies let the world be your provider and your starting point. And I mean that in a very React 16.3 technical sense. Because in terms of create context, in terms of having providers and consumers, this allows us to have our sensors and the machine learning code running through them filter through to provide us with usable insight about the world around us that then feeds into the way our code's going to work, using consumer, using render props. Again, I thank Mr. Dodds. But the other thing about this, the sort of the secret here, this is augmented reality. Because we're using reality as our starting point, and then helping our users, our customers, make better decisions about what's going on. There's nothing here about a camera preview. There's nothing here about a video feed. It's about augmenting the information that we have, and then being able to feed that back to make decisions that go beyond. Now, these are really early days of being able to make use of this technology, and I've done some things along these lines, and the code you just saw was stacked a couple layers on top of the React Native Vision package that I actually just released open source yesterday. And I've done some other work around Tesseract and CoreML as well. But really, I would like this to be a call to action for some of you in this room to join me, to help leverage this technology, to harness it so that we, as the universe of us, as React Native developers, are able to make the world our provider and provide superior and exceptional experiences to our users, and let reality be just the beginning. Thank you.